guys, thank you for tuning into my channel. Today I'll show you the modeling of an RCC beam. So here I have already modeled it. Now I'll show you how to model it, the complete procedure. But before that, let me show you some of the results. I've used the concrete damage plasticity. So let me play the animation for you. Over here, as you can see, this is how the beam is failing in compression. Let me just show the exterior edges. Failing in tension, I would say. Let us just wait for some time. So over here you can see over here that this diagonal failure is occurring due to this compression in beam, which is due to diagonal shear failure. Over here it is clearly visible. So it is a very good tutorial how you could learn how to get such type of visualization, how to model these beams in Abaqus. This is an RCC beam. I have used the HISD bars. This is a doubly reinforced beam. This is how the beam is failing in tension. Yes, not tension, compression. Pardon me. This is how the beam is failing in compression. If I just take it a little bit faster, yes. Now over here the complete beam is yielding. Now if you just want to check the tension failure of the beam, then I'll show you. See, this is how the tension cracks are propagating to the beam initially. If I just play the animation for you, so this is how the tension cracks are propagating as the time progress. These 2 points over here, as you can see, under these 2 points the loads are applied. That's why these 2 points are failing first. This is how the tension cracks are propagating into the beam. So it will be a very good tutorial for you to visualize the failure of the beam. This is how the beam is failing in tension. Previous one I have shown you, it was failing in compression. Show you the deformation of the beam. As the load increases, this is how the beam behaves. Now this beam consists of concrete as well as steel. This is how I have modeled it. Over here, as you can see, bottom bars are of 20 mm dia, top bars are 12 mm dia. Then we have stirrups over here, and also the stirrups I have kept it quite close with 100 mm spacing near the support and 200 mm spacing at the mid span. So if you want to check the figure, this is the beam that I have drawn, that I have modeled in Abaqus. If you want to check the cross section, this is the cross section. Now let me proceed with the modeling of the beam. So starting with the beam using solid element. So the beam will be of size 280, width 280 and depth will be 560. The dimensions are in mm. It will be of 6500 mm, that is 6.5 meter length. We have here the 6.5 meter length beam. Now to place the reinforcement at the assembly section, for make it easy, I want to partition it so that I can easily place the reinforcement over here. Even if you do not partition, it will work, but just to get the points, I'm doing it over here. I'll partition it using the data plane. That's why I'm creating data plane over here. Here I am selecting 60 because the top cover is 50 and bar dia over here at the bottom it is 20, so 50 plus half of that die will be 60. So this datum plane will be, this is the top datum plane, so top datum plane will be 50 plus 6, it will be 56. So you can modify it from here. Just now after this is the datum plane I have created, so it will be 56 and the bottom one will be 60. Show the direction of which direction you need the datum plane. And sideways I'll use 25 first, 35 mm cover. These are center to center distance for the rebars. Again and again, these are not required, just for the convenience I'm making it. Even if you do not create these surfaces, it will work for you. So now I am creating just to apply the loads onto it. Just select the plane, flip it this direction. So now my partition data plane creation is completed. I'll partition it. So let us use this view for partitioning the beam. Just create the data plane. First you have to select the cell, then create the data plane, then again select the cell, select the data plane, select the cell, select the data plane, select the cell, select the data plane, just select the cell and select the data plane along which you need to create the partition. If you have any doubt, any issue in creating or modeling any beam or anything in the Abaqus, just contact me. I'll help you. I'll leave my contact details in the description. You can contact me through WhatsApp as well as through email. You cannot call me in that number because that number is only for WhatsApp use. Now my beam modeling is finished. I will model this 20 mm diagram. 20. Here I'll use the wire and just simply create a wire and it will be a 6 by 00. wire. This is my wire. I'll just copy it and I'll make it 12 mm. Just now it will be easy for me to assign the sections. And again I'll have to create the stirrup. I'm just typing it str, create a rectangle. This will be center to center, so I'll be keeping it to 10 and 44. It will be 44. The diagram which I have shown, if you just calculate, it will get it like this. Now my modeling is completed, part generation is completed. I'll just create property now. So here property I have previously created in concrete. I have used concrete. This is the density, then elastic, then concrete damage plastic. These are the values, compressive behavior, and then I have tensile behavior, then concrete compression damage, concrete tension. So all these parameters have been assigned. For steel I have simply used the elastic properties. Next I'll assign the sections, so that will be steel. This is what I have created, the section steel. Next is my beam. So my beam will be of concrete. So these are I have created previously. Then I have 12 mm die bar, 12 mm die bar, and 20 mm die. So my section assignment has been finished. Now once the section over here, you will have to create these sections before section assignment. So you just go to create, select beam, and just go for it. Once you create it, you can easily be able to assign it. Now let us go to assembly, where I'll assemble all this bar along with these stirrups. So let us make it independent so that we can mesh it easily in the assembly section itself. I'll have to rotate this instance. My computer is a little bit slow, so let us just rotate this instance. I'll be rotating it vertically. So rotation is completed. Now what I'll do is just keep 20 mm bar along with the stirrups. So I'll select the instance. Here I have selected the instance first. Now I'll move the instance to here. Once I move it to here, I'll have to just copy it. Once I copy it, I can easily paste it on the beam. So now I'll copy it. As I've said earlier, copying I can use this. I'll be using this 52.5 center to center, and there will be 5 bars. Next, at the top I'll have to place the 12 mm bar. Okay, so there is a mistake. I have copied both 20 mm and 12 mm, so I have to delete the 12 mm bars because the 12 mm bar should have to be placed at the upper face. So I'll copy it now, take it to the upper side. So my 12 mm bar is been placed on the upper side. Let us copy. My computer is a little bit slow, so let us just copy it. This will be 70 and the number of bar will be 4. So I have now top and bottom bars. Now I will just copy the stirrups. So stirrups will be copied in this direction. So 23 stirrups at a spacing of 100. Then again it will be 11 stirrups at a spacing of 200, and then three stirrups at a spacing of 100 in this direction. So finally I'll have to, so this has been started from ending. You can start a little bit before the ending, as I have started from this end. So what I'll have to do is I just can move this you can just move all the stirrups from the equal spacing. So what I'll do, I'll select all the stirrups, then done. Then I'll check the distance now. How much shall I have to move? This distance is 100. That means I'll have to move the stirrups. Little bit slow this computer is, that's why I'm having some problem. Just select this point and it will be easier for us if we just create a point in between these two, so you can easily translate it. Now see over here, both the sides are symmetric. Let me show you once it is finished. Just check, see this part and this part, both the part are now symmetric. Now once it is finished, I will create a step. I'll use the dynamic explicit options create the dynamic explicit. I'll write exp. I'll run this for 5 seconds. 5 duration, 5 second duration. Keep everything as it is. After creation of this, go to output, select failure, damage, compressive and tensile damage, because it will make us easy to visualize that damage which I have shown in the shape. If you have any doubt modeling this beam or any model you are modeling, whether it's a bridge, you are from civil engineering, mechanical, or any other, and if you are looking for any problem, any solution in Abaqus, just contact me. I'll give my contact details. You'll get all these things information below in the description. So contact me through WhatsApp, or you can contact me through email. Now let us create the interaction. That means how these bars will interact with the concrete. I'll just embed it inside the concrete. So all the concrete has been selected here. Keep it as it is and just click OK. Next we'll have to apply some load over here. So I'll be applying some pressure, and this is why I have partitioned it, so that I can easily apply the load over here. Let us apply 50 Newton per square. All the dimensions here are in Newton and square. Let us place some boundary condition. So one side I will hinge it. It will be a simply supported beam. So one side is hinge support pinned, and the other side will make it roll up. Also will constant the torsional deformity displacement or torsional rotation. Torsional rotation at the roller support. So we'll be constraining U1, U2 and the torsional rotation, that is U3. So everything is finished. Now only meshing is remaining. Once we complete the meshing, we'll run this model. So as you can see, I have made it independent, so you can easily mesh it. Select a coarseness 550 and just go. So meshing is completed. Once meshing is completed, you can run the meshing has been completed over here. Now we'll go to the job. It takes some time because my PC is quite slow. I'll create a job for this model and this processor speed, and I'll submit it. Let's see. It will take some time, as I have previously analyzed it using this more I've just used this name mode. Previously I like it, but let's see how this works. So if you have any doubt, any query in Abaqus, any problem in modeling anything in Abaqus, just contact me. I'll help you. I have given my contact details at the description. In the description, all the details are available. I have given my. Here some error is shown. Not for number do not lie on the host element. Please check coordinates. So there is some issue. Let us check the host element. Let's check the surface. Okay. Okay. So this has moved. Okay. I have previously created it, but I have not moved it. So that was an issue for me. I have to move it inside the beam. So for moving, select this, use this point, any point you want. This is why initially I have partitioned the beam so that I can initially easily place these strips and beams. Now it will work. Let's check. This is the constraint. As I have said, my PC is very slow in these things, so now it will work definitely. So if you have any such errors or any problem in Abaqus, just contact me. I'll definitely help you. Just yet to run. Previously it was aborted because I could not place these bars inside the beam. Now let's see. This one is a previous file where I have completed the analysis. Let's check this. So it is successful. Now it will start running. So let us wait, and it will take quite some time. As I have already analyzed the beam, I'll show you the results, but let it get started at least. Once it is started running, I'll cancel it because I have already run it. The analysis has been already completed. So just about this, let me show you this. This file I have already analyzed. Okay. As at the beginning of this video, I have shown you some results. Let me play the animation once again for you. Look at this damage in concrete over here. The shear failure of the beam will be easily visible. At 45 angle, usually we know that diagonal failure occurs in case of concrete in compression. So this is what is visible, and if you just check the complete animation, it will take quite some time. And if you want to check the tension failure in concrete, you can see this is how. As I have applied two loads, two pressure loads, so directly below the pressure load for the tension crack is forming. This red line indicates the tension crack formation. Next we have this. If I can show you a little bit like this, this is how it works. So if you have any doubt, any query, any problem analyzing this, any problem in any model in Abaqus, just contact with me. My email details and WhatsApp number has been given here. Mail me, I'll reply you instantly. Thank you for tuning into my channel, and please don't forget to subscribe. If you press the subscribe button, next time I'll put some such amazing videos on Abaqus. You'll be able to get it whenever you want, so don't forget to subscribe. As the beam is failing because load is quite high, that's why the deformation is also quite high. It's the deformation. If we check this U2, this is how it is deformed. If I remove just this is the reinforcement part, this is how it bends. So thank you for tuning on to my channel. Thank you for today, and don't forget to subscribe.